some of the previous year questions on electronics. So the first question is, an operational amplifier has a gain of 10 in the inverting configuration and a bandwidth of 1 megahertz. At what gain will it have a bandwidth of 10 megahertz? So the answer here we have is for 10 the gain we have 1 megahertz. So if we have a 10 megahertz bandwidth, then the gain must be twice of that. That means 10 to the power 2. That is the correct answer here is option C. Then next question, a square wave of peak to peak amplitude of 500 millivolt has to be amplified to a peak to peak amplitude of 4 volt with a rise time of 3 microsecond or less. The operational amplifier used should have a minimum slew rate of. So slew rate is what? Derivative of voltage. So D output voltage divided by dt max, that is given by 4 volt, as we have here 4 volt peak amplitude minus 500 millivolt divided by derivative with respect to time, that is 3 microsecond. 3.5 divided by 3 microsecond we will have, then this ratio is equal to 1.1 volt micro per second. So the correct answer is option D. A first order low pass filter has a pass band gain of 10 and a cutoff 10 kilohertz. The gain of the circuit at 100 kilohertz in dB is. So active low pass filter act as an integrator and made using operational amplifier. So the circuit diagram for integrator is like this, and the voltage gain is given by this equation, V output by V input. So if we have this equation, so here AF is what? Pass bandwidth gain, that is equal to 10. F is the given frequency 10 kilohertz and cutoff frequency 10 kilohertz, and gain in decibels, we can have the formula of this gain into decibel, that is 20 log 10 V output by N. So if we put the values here, we will have clearly the given frequency, that is 10 kilohertz, that must be greater than the cutoff frequency 10 kilohertz, that must be greater than less than the 100 kilohertz. So from this we can say the option C is correct. An ideal differentiator using an op-amp has a high frequency gain above its maximum frequency, varying as. So for this we have the ideal operational amplifier. The circuit is given here. So the frequency response curve for ideal operational amplifier is as we can see, gain versus frequency. So the slope is given by 20 decibel divided by decade. That means the correct option here is A, plus 20 decibel per decade. To get an output of 1 from the circuit given below, ABC should be. So value of A, B, C should be. Here the correct option, if we simplify the circuit diagram, we will have, that is option B, 110. Okay. So next question, that is a weighted resistor network is used as 4-bit digital to analog converter. If the current through the LSB resistor is 10 microampere, what is the maximum current through the MSB? So most significant bit MSB that we can have here 62. Number of bit used here is 4. LSB resistor current is 10 microampere. So what is most significant bit? So 2 to the power 0, 1, 2 to the power 2 plus 2 to the power 3. So at MSB that is 8 into 10, 80 microampere. So option D. A mod 12 counter whose output is DCBA is to be made using a triple counter. The decoding gate for this will have the input as. So for mod 12 counter, triple counter, asynchronous, okay, asynchronous counter, that means J equal to K equal to 1. Then mod 12 counter 2 to the power n mod, n must have, that is 4, 2 to the power 4 is equal to 16, 2 to the power n must be greater than or equal to mod. Then if we have the diagram of like A, B, C, D, the input J and K, output Q and Q bar. So A, B, C, D we should write in decimal, okay, binary code 0, 1, like that. Then mod 12 as we have here, decoding term 0, 0, 1, 1, that means DCB bar A, DCB bar A, option D. Most metals used for temperature measurement in the form of a resistance thermometer have, actually the option here is B, that is positive coefficient of resistance. Which of the following is not part of lock-in amplifier? So among A, phase sensitive detector, B, integrator, C, differentiator, small signal amplifier. 65, the correct option is C, differentiator. Heterojunction devices are made up of gallium arsenide, aluminum, gallium arsenide, because they have different band gap but similar crystal structure, same band gap, similar crystal structure, same band gap but different crystal structure, different band gap, different crystal structure. So the option A is correct, different band gap but similar crystal structure. The output of a driver is 75 ohm. Maximum power is transferred when so here for this we have the option D. First, second are correct, third and fourth are wrong.